Welcome back everyone. Now that we have learned about the semiconductor conductors and insulators and that we have learned about all these gap things and all that such things, now we have understood that the electron is having to be free. But here we are not focusing about the conductors, we are focusing upon the semiconductors. So there are two categories of the semiconductors that we have to learn. First one is known as intrinsic semiconductor. So intrinsic semiconductors, and second one is known as extrinsic semiconductor. So you can understand by the word itself that something inside is happening, something outside is happening. So what are its meaning? So it's pure semiconductor. It means you are not doping or allowing anything else to come in between, like carbon, silicon, germanium. All these are pure semiconductors. You are not adding, subtracting, or doing just, you are not disturbing that in just one word. And what are the extrinsic? It is doped one. If you have ever read the things like doping, so you have understood this word. Otherwise, let me tell you. So doping is something when you add carbon with something else. So it forms a bond, like CO2 is also a doped form. So it is a doping of oxygen in carbon. So this is the doped form. In the doping, there is impurity. It makes it impure. So impurity comes with the doping. But we cannot use the purity. Instead, we use the impurity. Well, that is something weird, but that is the truth. Okay, so let's explore intrinsic semiconductor a little more. So there is something called as a concept that I'm going to teach you, which is very exciting, but I have kept it for the next one. So for now, let's explore about the intrinsic semiconductor, very basic thing about the intrinsic semiconductor. So as I have told you that intrinsic semiconductors must be carbon, silicon, germanium, and so on in their pure forms. Pure forms means like carbon, there are four electrons in the last cell, and I'm just drawing the last cell itself. You cannot tell me just looking at this if I do not tell you that which is the number. This is the same configuration for the carbon, silicon, and germanium, and all the group members that belongs to this category. Okay, all have last electron, four electrons in the last cell. So these all the things are called pure semiconductor or intrinsic. So these are intrinsic semiconductor. Okay, let me tell you about the extrinsic semiconductor now. So what are the extrinsic semiconductor? Let's take an example, like there is again something that is having four electrons. So this is intrinsic, but now we are going to be a little bit something, what I do say, messy or devil like. Okay, so now we have decided to put something else in making the bond. Like here I've decided to put something like 2 here and something like 2 here. In the last cell I have kept two electrons, element that is having last cell two electrons, like you can consider magnesium. This is carbon, magnesium, magnesium. I'm just including that. So each magnesium is contributing two electrons to the carbon, and as you can see, carbon can feel like that these all electrons are actually mine. So when you look closely, so there is something interesting happening here. One electron, two electron, three electron, four electron, 5 electrons, 6 electrons, 7 electrons, and 8 electrons. So it has achieved the noble gas configuration, but by using the magnesium. So here it is Mg2. I'll even write it as Mg2C, whichever way you like. I'm not focusing on the chemistry thing right now. So, but this is happening because of the doping. So doping means extrinsic semiconductor. So this is the fundamental difference. We can achieve our goals by using the extrinsic semiconductor because we are allowed to dope it. So the keyword here is doping, my dear friend. And we are going to explore more things on this one in the next one. So stick with me. Take care. God bless.